This one we're saying is this. If that criterion basically saying is this. This one is called the maximum shear stress. And how to calculate the maximum shear stress? And you can use the Moore circle, the techniques. And maximum shear stress basically is once you have more circles, then the radius give you is the maximum shear stress. Right? And this one is called the yielding. So what is yielding? Here I give you the comment. So the note 1. So what is yielding? The yielding is this. If we have the material and the sample of the material like the dog bone shape, and if we take the uniaxial loading, like put into machine, and we gradually increase the force, and then we measure the corresponding deformation. So for example, we put into the deformation in terms of the strain, we put into the increase in the force in terms of the stress. Then we measure the corresponding loading in terms of the measured strain. Then we would have such curve. Okay, we gradually increase, and again for ductile material, we are concerned about is to how much extent the material will be able to remain in elastic domain, which means Buchlow can predict their stress-strain relation, and to what extent the material will go one way, never come back. Go to the we call the plasticity. P-O-A-S-T-I-C-I-T-Y. Okay, the plasticity, that means once we go beyond certain threshold, say go to here, then if to that point, if we're going to release the loading will be going to release follow-up Buchlow. And then come to here, when loading is totally removed, we found there's a permanent deformation. And this is called a plastic deformation. We don't want to see this one. Okay, for all the design, if you could try to contain your stress strain in the elastic domain, go to plasticity. And to say so, the sacrifice is you have to use a lot of the materials, which means you're going to increase your the cost, and your design could be very bulky, very stubborn, heavy. Okay. But anyhow, so the onset of the onset to distinguish the elasticity and plasticity is called the yielding. So usually we define this one is called the Q's mean. So, sorry, I should say God bless you. Sorry. So this is called the yielding stress, okay? Yielding, I don't know, the people using strains. So basically here the yielding strength is sigma y. Then that should have the meaning of the stress, but the people just use the strains, okay? So that is for the yielding, and for tau y, so that means here, for this case, and right now, what is tau y? That is the shear stress corresponding to this case. So how to build up this number here, and that is the way here. So this is the uniaxial loading. So for example, we consider at the yielding point here. So if I would consider taking a small patch, on that small patch, we have, say, at the point of the yielding, we have sigma y. and sigma y is the yielding, and there's nothing here. So when we build a Moore circle, the Moore circle will be looking like this. This is point x, this is point y. So point x will be here, point y will be here. So at the y, its magnitude is sigma y and 0. Okay, so therefore the corresponding shear stress, the R, will be equal to sigma tau y. So this one in this case is sigma y divided by 2. Okay, so basically the tau y equal to the yielding strength divided by 2. Okay, and so with this criteria, we may look into a few scenarios to see what happened to different loading conditions here. So